Hey guys, I'm the Cyborg Sheep, and welcome to the Weekend Post. In this video, we're going to be taking a look at my favorite industrial connector, the NEMA connector. If you live anywhere in the US or Canada, then you're almost certainly familiar with these three-prong connectors that deliver 120 volts at up to 15 amps. You'll find these things just about everywhere, including on power supplies, power tools, appliances, and just about any device that needs a constant supply of electrical power. One of these plugs will probably be found. And the two-prong plug, which loses the grounding conductor, is even more common. The interesting thing though about the NEMA standard for electrical connectors is that it doesn't just cover the little guys like this. It covers everything from the little ends all the way up to these here chumboids that can handle an insane amount of power. So let's just dive right into these things, shall we? Starting out here, we'll do a quick run through of how the naming scheme for these connectors works. The first character here designates whether or not it is a locking or a non-locking connector. The next two digits denote the configuration. The next two digits after that denote the breaker size that it should be paired with. And the last character is whether it is a plug design or a receptacle design. Alright, taking a look at the connectors themselves then. We'll start with these smaller ones and then we'll work our way up to these bigger guys right here. The 515, like I originally talked about, I have a couple of designs here, all with different styles of construction. This one here, sort of a cheaper design. The cable gland is basically just made up by these two, I guess clamshells you would call it, of plastic, just coming together and squeezing on the cable. One of the other things about this style is that, I don't know if you can see there, let me see if I can adjust the light over. These screws, they don't have any clamp, basically. So like if I look at, for example, this one, there's a clamp in there, and I can show you closing it down. So you can see there's a slot for the cable to go down into. And when you turn the screw, the slot will close down and clamp onto the cable. Not so with this one. With this one, you really kind of, if you have a stranded wire, it won't work with this plug, because you'll have like the wires sticking out of the screw, and you cause shorts that way. I have found a sort of solution for that. Get yourself some of these here spade terminals. You crimp it onto the end of the wire if it's stranded, and that way the wires won't go all over the place when you try to screw it down onto the plug, and then that way you won't have wires going all over the place. And even in this case, you should also technically be using a ferrule. Even with this design, a ferrule obviously similar to this, but it's not really a fork design. It's more just sort of a sort of like round piece of sheet metal, and when you crimp it down, it just compresses all the strands together, keeps them together when you put them into a terminal, so that again you don't get the flyaways, which could cause shorts and be a problem generally. So I got three styles here. Got this cheap style with not so great construction. I got this slightly nicer style with the better construction, has the flag terminals, but it still has the using the flexible plastic as a hinge. So still not as great. I also have the El Primo. This is the Hubble design. Hubble, good brand, very good brand actually. I knew about these plugs for quite a while, and I thought I was wrong. Turns out I was mistaken. I thought these connectors didn't have any strain relief means, and thereby they weren't any much better. In fact, they might have been even worse than these ones. But if you remove the back shell of this, you can see they have these 3 prongs right here, and this is actually more similar to the Ceeform connectors. I'll leave a link in the description to a video about those. But this basically works by the more that this back shell squeezes or pushes onto the rest of the connector, the more these clamp down onto the wire. And I like that a lot better than this style, where it's just the 2 halves coming together and squeezing it from either end. This way it's sort of more, I guess, what's the word for it? It's more concentric with the shape of the wire. This one is sort of just, you know, half and half, and it risks shearing it off, kind of. Now, one final thing worthy of note about these connectors is that they have a rather interesting design flaw that severely compromises on the safety of these things. So, if I show you here, if I plug in this NEMA 515 into this socket, not all the way, of course, and I gingerly stick the multimeter across the live and neutral pins. There we go. Yeah, so you can see, oh, going all over the place. Anyways, these connectors, there is power between the plugs, even when it's not pushed all the way in. Or power between the pins, I should say, even when it's not pushed all the way in. Now, you'll no doubt know, in hotels especially, they have the plugs that they don't really have the greatest grip on the connector. So even though you push it all the way in, it'll fall out a little bit, but it'll still be connected. Not the safest thing in the world, especially when you have live circuits all over the place. So just keep that in mind. Oh baby, toasty. So anyway, that's just something to keep in mind about these straight blade style connectors. So, and worthy of note, of course, that it is also applicable to these twist lock connectors. I tested it when I was using this one, and on the subject of this one, let's get into building this adapter. The NEMA L515. This is the one application where I have seen this connector used. I'm not sure why GoTransnet hasn't changed this yet, but on the older dark green bi-level coaches, the locking connector is used instead of the straight blade connector. For those who are curious, the 2 orange lights on the tester means that I wired the adapter correctly. The next step up after the 515 is the 520. Similarly to the 515, this also delivers a 120 volt single phase connection. In this case though, it can deliver 16 amps continuously on a 20 amp circuit. These plugs, more specifically these aftermarket ones, would be used in situations like on heavy power tools. Some examples of this are contractor saws, mag drills, you know, the ones that blow the breaker on a 15 amp circuit right after you turn it on. The next step up after the NEMA 5 designation is the NEMA 6 designation. Similarly to NEMA 5, NEMA 6 plugs still retain the 3 pins in varying configurations to differentiate the current or breaker size that they are attached to. However, instead of delivering 120 volts through a hot, neutral, and ground, these plugs deliver 240 volts through 2 hot legs and a grounding conductor for safety. NEMA 6 plugs deliver 240 volts in this way due to the way the electrical system in the US and Canada works, that is, with split phase power. Now in future, I'll be making a video about split phase power and how it works. But basically speaking, it's similar to the robotic arm where I had the center tap transformer. So like NEMA 5, NEMA 6 plugs also come in 15 and 20 amp designs. And it is interesting to note that for both the 520 and 620, T-slot receptacles are often available. T-slot receptacles are compatible with both 15 and 20 amp plugs, keeping within their respective voltages, of course. And then once again, beyond the 20 amp configuration, we have both the 30 and 50 amp configuration. Now it is interesting to note that for these standards, the NEMA 5, the NEMA 6, the NEMA 14, and so on, 60 amps is very often the biggest size you can get. Beyond 60 amps, very often a Ceeform connector would be used. Ceeform has the 125 amp rating, which fits the bill just perfectly for applications where you would need more than 60 amps. For applications beyond 125 amps, very often, instead of going with a connector like, say, a big Chungus one that has multiple pins, multiple connectors would be used with single cables attached to them. In the UK, as it has been demonstrated, that's often achieved through a connector called Power Lock, or Power Safe as it's often called. Here in North America, what we use is called Cam Lock, and I probably will be doing a video in future about those connectors. They're very interesting, very cool. And these aftermarket plugs are particularly interesting because they often can serve both purposes through the use of these cross holes here. And I don't know if you can see there, but if I adjust the light, you can see on the bottom of those diagrams. So two parallel blades can be a 50 amp plug, and then the two inline blades are the 30 amp plug. So that's just something interesting. After the NEMA 6 comes the NEMA 7 and 24. These two standards, though, go relatively unused, since they are single-phase systems derived from a three-phase supply, and see relatively little use outside of the commercial sector. Moving up to something that is a little bit more common, though, we have the NEMA 14 standard. These plugs, the 50 amp and 30 amp versions in particular, see some of the heaviest use, being used on things like ovens and dryers, for example. Now, perhaps a little less common, but just as intriguing, are the L14 designation of connectors. And this is where we get into the twist lock style of connectors compared to the regular straight blade connectors that we've been going over so far. Now, these connectors are very interesting because they lock together. So, you insert them like a normal plug, but then, to lock them, you twist them. Like so. Starting out with these here Chungus lads, these guys are used for the heavy duty jobs. These guys here can deliver up to 30 amps and all three phases of a three-phase industrial supply. These connectors are most commonly used for industrial or manufacturing applications, where you'd have like a ceiling or a drop ceiling of just power supplies, and you'd have cables hanging down from that drop ceiling, and you have these connectors on the end, and then you could hook up, say, different kinds of machinery to them. So there you have it. NEMA connectors. pretty interesting when you get down into it. But anyways, guys, I think I'm gonna leave the video at that. Hope you guys enjoyed. Subscribe if you're new. Hit that like button if you liked it. And I'll see you dudes in the next video.